Welcome to this video. Today we're diving into the awe-inspiring world of tropical cyclones. This video will provide an overview on how these storms form, what gives them their destructive force, and a phenomenon known as rapid intensification. Specifically, we will discuss recent findings indicating that those events are becoming more frequent in a warming climate. Buckle up, we're in for a ride. So how do these atmospheric powerhouses form? Well, a few ingredients are necessary. Warm water, specifically above 26.5 degrees Celsius, moisture-rich environment, little change of winds throughout the atmosphere, also known as wind shear, and ideally a pre-existent disturbance or instability. If all these conditions are met, thunderstorms can develop and sustain themselves in this environment. About 5 degrees removed from the equator, those thunderstorms will begin rotating around a developing center in the mid-layers of the troposphere, thanks to something known as Coriolis force. With sufficiently low wind shear, surface low pressure will develop below this mid-level center. Once both pressure centers are closed off, we talk about a tropical system. As long as the conditions necessary to spawn the system are maintained, its center will tighten, increase the pressure gradient around it, and by doing so increase its maximum sustained wind speeds. Depending on its strength, measured by 1 minute sustained wind speed, this system will be called a tropical depression for storms less than 34 knots, a tropical storm 64 knots or less. When these winds reach and exceed 64 knots, these systems will be known as hurricanes, cyclones, or typhoons, depending on where you are in the world. We're not doing the complexities of the ongoing processes in tropical cyclone formation and their life cycle justice here. So if you would like to learn more about how such storms develop, please follow the links in the description, especially the National Hurricane Center at nhc.noaa.gov and Colorado State University's CIRA are great starting points and resources. Now, let us talk about the strongest such storms. Tropical cyclone strength is often expressed through categories on the Saffir-Simpson scale, after its creators Herbert Saffir and Robert Simpson in 1971. We will focus on those cyclones that exceed wind speeds of 112 knots, equivalent to Category 4 on the scale. Multiple papers, including one written by Song and others, find that about 90% of such storms experience a phenomenon known as rapid intensification at least once in their life cycle. Rapid intensification is defined as a storm strengthening equal to or more than 30 knots in 24 hours. Often, those periods of strengthening coincide with significant deepening of the storm, more than 24 millibars a day. Statistically, that corresponds with about the 95th percentile of all recorded intensification periods in any storm globally. Find some papers linked below the video to learn more about the statistical prevalence of intensification in tropical cyclones. Okay, so now we understand some of the fundamentals of how some storms can attain their unbelievable strength. Let's shift gears and think about our warming planet now. Intuitively, how do you think added heat will impact the frequency and intensity of our storms? Luckily, there are many studies discussing just that question. In October 2023, A.J. Garner of Rowan University found that while the frequency of tropical systems in the North Atlantic Basin is largely constant, if slightly increasing, the peak intensification rates of storms in this basin is significantly higher than before. When comparing storms intensifying with more than 20 knots in 24 hours from the 1971 to 1990 period to the more recent 2001 to 2020 period, she suggests that today's storms intensify in 24 hours about as much as they did before in 36 hours. Similar results were found by Song, Duan, and Klotzbach in 2020 for the Western Pacific Basin using similar methodology. Additionally, Kanta and Sudhir find that storms are more likely to rapidly intensify more than once in their respective life cycles. There is ongoing debate in the scientific community what factors contribute to the statistically relevant increase of intensification rates in tropical cyclones. Though atmospheric and oceanographic changes due to global warming in a specific basin can vary substantially, warmer sea surface temperatures allow release of more latent heat to its immediate surrounding, in turn providing more potential energy to developing storms. Earlier, we showed the infrared loop of Hurricane Otis, which in late October 2023 intensified at a staggering 100 knots in 24 hours. Well, still subject to research, early indications suggest that such intensification would have been physically impossible to attain in past decades. This brings us to the end of our video. Thank you for taking the time to follow this project. Find all citations below and do not hesitate to reach out with any questions. If you like this video, please comment with what you would like us to discuss next. Consider liking and subscribing, it helps out a ton. Until next time.